Okay, let's look at problems 8 through 12. Now we're going to work these using the calculator, so I'll show you how to do that. This is problem number 8. S of t equals 4t plus 1. And for part A, I want the average between t equals 1 and t equals 5. Now this is not much faster than the way we were doing it before, but it's an option, so let's look at that. Second plus 7, 1, 2. So I'm clearing the calculator. Go into the equation editor and put the function in. 4x plus 1. And then I'm going to graph it. You can see the graph there, but I really want the table. So second table. Okay, and I'm going to write this as S of 5. Now S of 5, you can see, is 21. This becomes 21 minus S of 1, which is 5, all divided by 5 minus 1. Well, 21 minus 5 is 16 over 4. So this turns out to just be 4. Next, I want the instantaneous velocity when t equals 2. T equals 2. So I'm going to graph this. I'm going to go to second trace. Now what I'm looking for is the derivative. That's what dy dx means. So press 6. And then I'm going to move over to 2. So you see where it says x equals 0? I'm going to move over until x gets to, I can probably just type it in, 2, and then press enter. And you can see dy dx equals 4. So that's my instantaneous velocity. For number 9, it's S of t equals t squared plus 4. And this is going to be from t equals 0 to t equals 4. And I want this when t equals 1. So I'm going to go back to my equation editor, clear that out. I'm going to put in x squared plus 4. Go to my table. And I see that when t or x is 4, I get a 20. So 20 minus, and at 0, I get a 4. Over 4 minus 0. So this is 16 over 4. And I get 4 again. Now graph it. Press second trace. And once again, I want this derivative here. This rate of change is what a derivative is. 6. My value is 1, so I'm going to enter 1. Press the enter key. And I see the derivative is 2. So dy dx equals 2. Let's do number 10. 10 says S of t equals t squared minus 3t plus 2. I want to go from t equals 0 to t equals 4. And I want t equals 1. So let's try this one. Go to the equation editor, put in the function x squared minus 3x plus 2. Let's clear that out and clear it first. X squared minus 3x plus 2. Let's graph it. Get this. I'm going to look at the table. And I need 4. That's going to be 6. 0 is 2 over 4 minus 0. This becomes 4 over 4, which is 1. Now, I need to find the instantaneous at 1, so second trace, I want number 6, dy dx, and I'm going to put in a 1, and I see that dy dx equals negative 1. Now, dy dx is what we call a derivative, but that's the same as an instantaneous rate of change. So for number 11, we've got s of t equals t cubed plus t minus 1. So I'm going to go to the equation editor, clear it out. I'm going to put in x cubed plus x minus 1. Graph that. Okay, now let's look at the table. And I am looking at t equals 2 to t equals 7. So 7 is 349. 2 is 9 over 7 minus 2. So this is 340 divided by 5, and that will be 68. And I want to find the instantaneous when t equals 2. So I'm going to graph it one more time. And I want to second trace dy dx number 6, and I'm looking at when t is 2. So in this case, dy dx. Now this is 13.000001. So this uses numerical, I'm sorry, this is probably going to be a sweet 13, so I'm going to put it down as 13. I don't think it's going to be 13.000001. And the last problem is number 12. S of t equals 6 over t plus 2. And I'm going to go from 1, you can't see that, 1 to 7. I don't know how much of this you weren't able to see, but I'll put it all back up again. Okay. So I'm going to go from t equals 1 to t equals 7 for the average. So let's go to the equation editor, clear it out, and 6 divided by x plus 2. I'm going to graph that, and I get this. Now I'm looking for the average velocity from 7, so at 7 I'm going to get 0.66667. Hold on just a minute, Elijah, and I'll be right with you. And at 1 I will get 2 over 7 minus 1. This is 2/3. 2/3 minus 2 is going to be a negative 4/3 over 6. And to divide that, we invert and multiply. And that gives us negative 4 over 18, which is negative 2 over 9. And the instantaneous velocity, if I go to second, well, let's just go to graph. Now I want to find this at 4, so second trace 6, 4. do that again. Second trace 6, put in 4, and I get dy dx is negative 0.166667, and this is at t equals 4. Okay, let's stop there.